let's do a functions review. So perform the indicated operation. Remember this?
No.
A little bit? Okay, so how this is going to work is we're going to talk about our steps as we do the problem, okay, to kind of refresh our memory. So I'm going to write steps as I go. So what is my first step? Yes, so let's call that rewriting it. Let's rewrite it. So I'm going to rewrite it to look like h of g of x. What's our second step? How do we work with these? Alright, got it. We work from the inside out. So I'm actually going to use color with this. I'm going to work from the inside out. So we're going to have h of whatever g of x is. So if g of x is red, then whatever is red goes in there. So what goes in here? X squared plus 3x. So work from the inside out, and we need to substitute, right? Now what do we do? I guess you could say substitute again, but now I'm going to consider the outer function, right? So I'm going to say apply outer function. That's kind of specific, right? Not just solving, but working my way from the inside out. So now I need to apply the outer function. So h of x is right here. Here's my outer function. 2x's plus 5. Well, I know my x's are, it's this right here, this whole thing. So 2x's plus 5. And I know my x's are what's in the red there. So finally I would have 2x squared plus 6x plus 5, and I'm done. Questions? No questions? We're good? Give you guys a second to make sure you have all that down. Okay, let's move on to number 2. Find the inverse of each function. So step. Do you remember our first step? Rewrite it. Good job. So I would rewrite this as y equals 2/3 x plus 10/3. What's my second step? Interchange x and y. And my third step? Solve for y. How would I solve for y on this one? You think so, huh? Let's clear the denominator. Let's multiply by 3. You could have subtracted 10/3 first, but I think this is easier. So I get 3x equals 2y plus 10. Subtract 10 from both sides. So over here, I have 3x minus 10 equals 2y. Now, at this point, you could either We got to divide by 2, right? You could divide the whole thing by 2, or divide everybody by 2. I prefer this way, because then it just, I don't know, I'm used to seeing it. It's simplified completely. If I wanted to graph it, it'd be easy to graph. So when I get that, is it okay if I put my y on this side now? Is it okay with that? Y equals, I'm going to put it in slope-intercept form, 3/2 x minus 5. It's my final step. Rewrite it again in the function form, but it's not just a function anymore, it's the inverse function. So this would be f of -1 of x, inverse function of x, equals 3/2 x minus 5. Questions? Did you guys finish writing that? I'm sorry? That is what the inverse sign looks like. Right there. That is the inverse of this. Okay? If I were to graph it, they would look like reflections. Over what? Reflections over what? Y equals x, right? Okay, of course. You guys still need more time writing this down? Everybody's good? All right, let's move on. Number 3, use composition of functions to determine whether the two functions are inverses. It's going to be fun. What's my first step? It's like the same steps as the last one, right? Rewrite it. Let's write the steps out before we do it. What's the second step? No. Work from the inside out. Then substitute. Then apply outer function. And then on this one, you have to consider whether it is indeed inverses. Consider, are they inverses? Well, you guys finish writing that down. Okay, so let's start with our first step. Let's rewrite this as a composite function. So I have f of g of n. And we also have to consider g of f of n. We put a line down the middle. Consider them separately. Okay, so inside out. Let's get some colors going on. So, from the inside out. Does it bug you guys that I do them side by side? No, it's fine? Okay. Okay, so we need the blue to go here and the red to go here. So what is the red? N minus 1. I don't know about you, but as soon as I see color, it just all makes sense. It does? It does not work that way for you? Is that what you're telling me? Okay. Now I need to apply my outer function. F of n is my outer function, n plus 7 over 2. N plus 7 over 2.
Isn't it negative?
This one? This says n plus 7 over 2. Isn't that what I wrote? N plus 7 over 2.
thought there was one, but there isn't.
There is not.
So we're all three.
Okay. My outer function over here is g. G says n minus 1. Every time I say a variable, I'm just going to write parentheses, right? N minus 1. Get my color in here. Even though Ryan, it doesn't help Ryan, we're going to use it. Right? It matches. It matches. I better make sure it matches inside. This is, by the way, a very excellent problem, and you'll see why in a second. Okay, let's simplify. N minus 1 add 7. N minus 6 divided by 2 plus 6. Thank you. Just making sure you guys are paying attention. Okay. What about this one? It is not n plus 6 because when you subtract 1 on the outside of that parenthesis, you have to make sure they have the same denominator. You can't just subtract. This is halves subtracting 1. You can't compare apples to apples until they look like apples and apples. This is apples and oranges. Me too. Okay, guys, ready? So this is actually n plus 5. But does everybody see that they use this as a distractor? Because you could have done plus 7 minus 1 is 6 and gone, oh, yep, they're inverses. They're not inverses. They're not inverses of each other. These two do not match. Questions? Why did I subtract? Isn't negative 1 the same as negative 2 over 2? You can't, that's when we were talking about apples and oranges. I can't subtract these two because this is something being divided by 2. It's just like this. Can you subtract 1/2 minus 1? Is that 0 over 2? No. 1/2, in order to subtract that 1, don't I have to turn it into having a common denominator? Right? I did the same thing. I had to make sure it had a common denominator before I subtract them. I didn't have to do that up here, right? Because 7's already over 2. This is the same thing as saying this. Right? Yes, Jesus. Keep going. Keep trying.
The n plus 6, we have to n plus 6 over 2.
Yes.
Did we do separate for n
Yes.
over 2 plus 6 over 2, n over 2 over 3?
Yes.
Plus.
Thank you. Just it again. I'm seeing the negative right there, and so I'm wanting to put a negative. It would be, you would be correct in saying n divided by 2 plus 3. Yes, that would also be correct. Correct. Okay. Any more questions? All good. All good questions. Erase this. And move on. Find the inverse of each function, then graph the function and its inverse. It tells me to find the inverse first and then graph it. I think it's easier to do it the other way. Follow me along with this. If I were to find the inverse of this and then graph it, how would I know if I'm wrong? If I make a mistake finding the inverse and then graph it, isn't it just a mistake?
Yeah.
What if I graph it first and then find the inverse? Then I could see whether or not they match, right? It's like doing a double check. Let me proceed and then we can talk about it. So my steps. Whether you graph first or you do it algebraically first, steps are still the same. So my first step is to what? Common theme. Rewrite it. So I would rewrite this as y equals. Now, because my second step is to graph or do it algebraically, makes a difference on how I'm going to go from here. So I'm going to graph first. So wouldn't I change this to negative 15 over 5 plus 6x over 5? Right, because I want to put it into slope-intercept form and graph it. I need to further change this then. It would be y equals what? 6x or 6/5 x, right? Minus what? 15 over 5 is negative 3. Now I can graph that easily, correct? Just go shift down 3, up 6 over 5. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. There's my first line. Let's make it blue. Now, let's find the inverse. When graphing, what's my next step to find the inverse of that? Let's do this first. Oops. No wonder. How would I find the inverse of that? Opposite points, right? Or, actually, it's the same step as you do algebraically. What's the next step we would do algebraically? Anybody? If I had this, what would I do next to go algebraically? I would interchange x and y. Interchange x and y. Well, in order to interchange x and y graphically, don't I just write two tables? I've got my function, and then I've got my inverse function. So my function, I already got a point right there. It's 0, negative 3. So what would my inverse function look like? Negative 3, 0. I've got a point at 5, 3. So that means I also have a point at 3, 5. See what I mean by 1, 2, 3, 4, 5? I just think this is easier. But it does have a one flaw. You ready for my one flaw? Does that look like an inverse function to you? Now, normally, if this was shifted just a little bit more, I could count my slope, put it in slope-intercept form, I'd be done, right? I would know the slope of that line, if I knew the slope of that line and the y-intercept. But do I know the slope and the y-intercept? No. Well, the slope would be inverses. You're right on that. But the y-intercept, I don't know the y-intercept. Can you look and tell me for sure what that is? No. That's the only problem. So I need to go back. If it was crossing on the line, on the intersection right there, then you could just look. But you can't. So I will quickly do this algebraically. So I'm going to interchange. I'm just going to go back. So my fourth step is to rewrite. I need that inverse function, right? Well, I can't write it because I don't know exactly what that is. So I need to interchange. I just need to go back to this step right here. Go back to 3. Interchange x and y. So I would have x equals 6/5 y minus 3. How do I solve that? add 3 first. Gives me x plus 3 equals 6/5 y. What am I going to do with that 6/5? Not just multiply by 5. What would be even more efficient? Five over 6. Multiplying by 5 and then dividing by 6 gets you the exact same result. I just think this is a little faster. So that makes this cancel completely. And I'm left with y equals 5, 6x plus 5 over 2. Because when you distribute, the 6 goes away, it turns into a 2, right? So if I were to rewrite that guy right there, it would be the inverse function of x equals 5, 6x plus 5 halves. So like Janelle said, the slopes are inverses of each other. And does that look like 5 halves? Yep. Because when I multiply 5, 6 times 3, it's really 3 over 1, which is really 2. How you guys doing? Pretty good? I'll give you a second when you're still writing. Okay, so let's go to, actually, I'm going to go to number 6 and come back to number 5, and you'll see why. So just, I don't know.
We write the after notes so that I could say, do it right on the paper.
Ryan, you can do whatever you want. That's the beauty of your notes.
But will you go back to 6 after yourself to copy it?
No, I won't do that. Okay. Brian, what you're asking is you want me to do number 6. You're just going to sit there and watch me, and then I go to 5, and then go back to 6 and let you copy it down. Yeah, it's not going to happen. Okay, so number 6. Y equals -2 plus 2 times the square root of x plus 4. Identify the domain and range of each. So my steps. Number 1. First of all, that's not like in vertex form, right? So we're going to rewrite it to look like this. Correct? So if I rewrite it, this isn't saying -2 plus 2, right? I had somebody ask me, well, isn't that just 0 in front of there? Well, let's put some kind of value in there. -2, isn't it saying 2 of these? What if I had that? Then wouldn't that be plus or minus 4? Very well. Very good. Well, no, it's not plus or minus because it already tells me that it's plus. But, no. But he's thinking outside the box. Makes me happy. Okay, so y equals. So I'm going to put this back there. So I have 2 times the square root of x plus 4 minus 2. Secondly, I need to consider what is under the radical sign. So x plus 4 must be greater than or equal to what? 0. So x must be greater than or equal to -4. That means my domain is x such that x must be greater than or equal to -4. Now I'm going to consider the behavior. Consider the behavior of this graph. This is shifted, we've learned, to the left 4, right? How else is it shifted? Down 2. Now the range is in control of what's going up or down, right? So my range would be, just from thinking about the behavior of the graph, I know that my range is y such that y must be, I should really think about the behavior of the graph. This is a plus sign, right? That means this is, first we're going this way, then we're going this way, and where's it going to go? To the right or to the left? Does that work, Possum? The only reason it would go to the left or go down would be if you had negative signs involved, right? Otherwise, it always goes this way. Ryan? Stretching with your hands flat out. Okay. Oh. You're just trying to psych me out. Okay. So consider the behavior. So y must be greater than or equal to what? -2. Maybe we should have done the other one first.
Now I go next. What?
It'll be okay. It will.
No, because it is.
Oh. Yes, ma'am. This, please, you guys, she's got a great question. This is just rewritten so I can consider the behavior. Because once it's in this form, I can see what it's going to do. It means it's going to go to the left, and it's going to go down, right? That's the only reason I put it in this form. After that, your next step is to figure out this controls the domain right here. So that's why we set it, because we have to have it greater than or equal to 0. Okay? We should have done the other one first. I should have done the other one first. Let's go to the other one, okay? Because then it's got a graph associated with it. You guys still need this? All right, let's go back to this one. So my steps are, they start off exactly the same, correct? This says sketch. We're not going to sketch it. We're going to full on graph it, okay? So steps. The first thing I would do is rewrite as, I'm going to put plus or minus. No. This is better. X minus H plus K. All right, so that's not exactly like that. We need to do y equals the square root of x plus 2 plus 1. Okay, what do I do next? Get the domain and range. See why I was trying to skip over the next one? Because we just did that. Okay, so how do I find the domain and range of this? Under the radical. So x plus 2 must be greater than or equal to 0. Therefore, x must be greater than or equal to -2. So my domain is x such that x is greater than or equal to -2. And my range is right there in front of you when you consider that k value, right? That k value is where it's shifting up or down on the graph. We don't have to worry about whether it's going negative this way or negative this way because we don't have any negative signs to worry about, correct? Therefore, we know that y must be going greater than or equal to what? Where's my boundary? 1. Good. Change? Something like Like when would it be y is less than 1? When it would be less, okay, let's consider that. So if it was -2, +1, this is where we're going to start right here, right? So if I were to make this a negative sign in here, then that would mean it would be frowning. That's still greater than. If I put the negative sign out here, yeah, I'm going this way, right? That would be y is less than 1. Does that make sense? So you don't have to worry about it being less than unless you've got a negative sign. Makes sense, right? Less than means negative sign. Okay, so I'm going to go ahead and shade these too. So mean would be everything to the right of that dot right there, correct? And my range would be everything above it. So that means my graph's got to be in there. That helps you with graphing, right? So, last thing I need to do is a t-table. So x, work, y. Well, we already have one value. If I put in -2, what do I get? I get 0 plus 1 is 1. -2, 1. How many points do we need? Do you guys remember? I only required you guys to have 4. But 5 is more thorough, but I only required you guys to have 4. Okay, what would be the next smartest point to put in there? Ooh, you're right. -1 would be. I didn't catch that earlier. -1 plus 2 is the square root of 1 plus 1, which is 2. -1, 2. What would be the next smartest point? 2. Because if I put 2 plus 2, I would get the square root of 4 plus 1, which is 3. So 2, 3, 7. If I put 7 in there, I would get the square root of 9 plus 1, which is 4. Pretty easy, right? Questions? I'll let you guys finish copying that down. Okay, so let's go to our closing thought. Nobody move? What did you learn today? Function review. What can the composition of functions tell us? How can I use composition of function? To tell me whether or not they're inverses of each other. Awesome, got that one. The person next to you is absent. How would you explain how to find the inverse of a function graphically? How do you find it graphically? You're interchanging x and y. It's the same thing graphically as it is algebraically, right? You're interchanging x and y. That's all you're doing. Okay, on your assignment sheet, sketch the difference between these two functions for me. Sketch. Sketch means a rough sketch based on your behavior of the graph, right? So go ahead and do that. Good job today, guys. I'm going to show you something with GeoGebra that compares a couple different things in a second here. But I'm going to pass out homework right now. What's this one look like? No. Right 4, and then it's normal, right? This one, you have to consider the fact that it's a negative. So what really is this? It's frowning, right? Frowning looks like this, right? The +4 means it shifted to the left. And this is a positive sign out front here, so it would be the positive half of this graph. So it would look like that. Questions on that? All right, let me show you guys this GeoGebra. So somebody asked me in the last class, what would this graph look like, guys? I've still got 3 minutes. Somebody asked me in the last class, what would this graph look like? Because I said, what is that 2? What does the 2 do? Normally, when we do parabolas, it would make it shoot up faster, right? But when it's on its side, it makes it wider because it's pulling it up faster. Does that make sense? So this would make this wider. Somebody asked me in the other class, then what would change, how would it change if it was inside like this? Think about that. Okay, so stop packing up. I've got a thought-provoking question for you. Why would it change the vertex? Because if you equaled it to 0, it would shift the vertex. Not only would it shift the vertex, but it would no longer be, it would look like this. 2 times x plus 2, that's how the vertex would change, right? So instead of being shifted to the left 4, it would be shifted to the left 2. But this 2 doesn't have as strong of an impact inside as it does on the outside. Right? Because if you take the square root of 2, that's what? 1 point something? You're multiplying by something smaller than if it was on the outside. That's going to shoot up further. So I graphed them both on GeoGebra. So this one right here is with the 2 on the outside. See how it's shooting up really, really wide? And this one is with the 2 on the inside here. Pretty cool, huh? Shows you how it affects it. All right, we're done.